Hello students, welcome in your online sessions. As you all know, we are studying chapter number 1, that is real number. Already 4 video lectures of this chapter has been uploaded on the website. This is the 5th video lecture of the real number, and that is going to be our last topic of the chapter. Now till now what we have discussed, let us do the quickly revision. In the exercise number 1.1 we have studied what is the Euclid division lemma, and using that we have solved the HCF. Then we solved few word problems related to the Euclid division lemma. That was covered. In exercise number 1.2 we have studied the fundamental theorem of arithmetic, which was including to find out the LCM and HCF using your old method, right, by doing the prime factorization method. Then in 1.3 what we have proved, that is in the previous video, that is video number 4, what we have proved, we proved how a number can be proved as an irrational number like root 5, root 2, 2 plus root 3, such thing, how it can be proved as an irrational number, we have done it. Now this is the last topic, that is exercise number 1.4, and basically it deals with again rational number and irrational number. Now let us start our topic, rational number and irrational number. So if you will see rational number and irrational number, if you compare, so first of all, rational number, it is in the format of P by Q. Q is not equal to 0, and P and Q are the co-prime numbers, right? This cannot be written in the format of irrational number. That is the one difference. The major difference is this: all the terminating numbers are but obvious going to be a rational number, like 0.2. It is a terminating decimal expansion, right? 0.2, 0.5, 0.7. So all that terminating decimal expansion will be called as a rational number, right? But if the numbers are non-terminating but recurring can also be called as a rational number, like 1 by 3. 1 by 3 is a P by Q format, but if you divide 1 by 3, you'll be getting a result as 0.333333333 and so on and on. Means you'll not have a terminating decimal expansion. It is non-terminating decimal expansion. It will not terminate. So if it will not terminate, means what we are calling it as? We are calling it as a non-terminating decimal expansion, but it is a recurring. What is the meaning of recurring? If you see 1 by 3, it will be coming, the answer we will get as 0.33333. So a specific number is continuously repeating. Specific number, it is continuously repeating after certain positions. So you can say that after the position number 1, the 3 is repeating. Suppose such kind of number is there, 0.207, 0.207, 207, 207, and so on. So a specific number is again repeated after every 3 digits. So 207, again it is 207, again 207. A specific number is repeating after certain position, that is called as recurring decimal expansion, right? So all the recurring decimal expansion which are non-terminating, they are termed as a rational number, okay? And here, irrational number, so only one category. They are non-terminating. They will never terminate, because if they will terminate, they will be coming in the category of the rational number. So they will always non-terminate, and after non-terminating they will be non-recurring as well. Non-terminating and non-recurring, like 0.120, 1200, 12300. See here, nothing, no number is specifically repeated, like 120. So it has to be 120, 120. If 1200 is there, that same number should be repeated. But here 120, 1200, 12300, no specific number is repeated. Each and every number is changed if you compare with the previous one. So they are called as a non-terminating, non-recurring decimal expansion, and they are termed as an irrational number. Now this is not new for you. You have already learned this thing in the 9th standard. Now the next topic, how you will get to know that a particular number is having a terminating decimal or non-terminating decimal. Means, first of all, this is a special category. It will be a non-terminating and non-recurring. But if a number is a rational number, it can be written as the formula P by Q. But how that P by Q number, you will call it as a terminating or non-terminating. First method, you can do the long division. For example, 1 by 3 is there. 1 by 3 is there. Do the long division by dividing 3 with 1. Right? Here we'll put 0. Here 0 will come. 3 3s are 9. 1 again 0. 3 3s are 9. 1 again 0. 0.33. This is how you'll get to know that the number is a non-terminating recurring decimal expansion. But if I'll ask you, don't do the long division method. Don't do the long division method and again tell me that whether the given number are terminating or non-terminating. So for that, all the terminating decimal expansion will have a specific characteristics. What is the specific characteristics that we are going to see in this video lecture? Okay, so let us move forward. So moving further, so how we can say that a particular a rational number will terminate or it will not terminate. So for that, you have to see any rational number can be written as a format of numerator upon denominator, right? Numerator upon denominator. Now they should not have any other common factor. For example, suppose the 5 upon 15 is there. 5 upon 15 is there. So they are not in the standard format of a rational number because they are having the common factor. Further, you can cancel it, that both numerator and denominator you can cancel it as a 5 1s are and 5 3s are. So your answer is 1 by 3. So again I am telling you what we are going to derive. We are going to study about rational number. There are two categories in the rational number, terminating and non-terminating and recurring. How you can judge by observing the number whether it is a whether it is a terminating decimal expansion and non-terminating recurring expansion. So for that, the first job you have to do, you have to check your number. It will be in the format of numerator and denominator. Both numerator and denominator should not have any other common factor other than 1. Like here, 5 by 15 is there. So you cannot call it as a standard format of the rational number because 5 and 15 will have a common factor as 5. So first job is to cancel it. Okay. Then next job, you have to look at the denominator, only and only denominator. After you have converted in the proper rational number, look your denominator. So denominator is 3. Denominator is 3. So for terminating decimal expansion, denominator part should have power of in the power of 2 and 5, 2 or 5 or both. 2 or 5 or both, meaning to say that whatever your denominator is there, do the prime factorization of this. Like here 3 is there, so 3 is again, it's a prime number, but the prime number which is there in the denominator, it should be only as a power of 2 or as a power of 5 or as a power of both 2 and 5. No other prime number is required in the denominator for any rational number to be called it as a terminating decimal expansion. Meaning to say that, let me make it very short. Here your denominator is 3. So it is 1 by 3 only. You cannot convert. Can you say that the 3 is a power of 2 or power of 5? No, you cannot say that. But 1 by 10. 1 by 10, what is the answer of it? 0.1. Is it a terminating decimal expansion? 1 by 10 is equal to 0.1. It is a terminating decimal expansion. So if you do the, okay, any other factor is there? Any other common factor is there between numerator and denominator? No. So if no common factor is there between numerator and denominator, just you have to do the prime factorization of denominator. You have to do the prime factorization of denominator. So here you can say that for terminating decimal expansion, prime factorization of denominator part should come in the power of in the power of 2 or 5 or both. Like here 1 by 10, it is a decimal expansion 0.1. So if you do the prime factorization of 10, 2 5s are 5 1s are, so 10 can be written as 2 into 5. So 1 upon 10 is equal to 2 into 5. So see the denominator. That denominator is only containing the power of 2 and power of 5. Only 2 will also do, only 5 will also do, or both will also do. But if any other prime number is coming in the denominator apart from 2 and 5, if any prime number is coming in the denominator apart from 2 and 5, that will not be called as a terminating decimal expansion. That will be a non-terminating decimal expansion. Again, I am repeating my words. How you can say that a particular rational number is terminating or non-terminating? So first of all, that rational number should be in the standard format, means there should not be any other common factor between numerator and denominator other than 1. After looking at this aspect, now go for the prime factorization of denominator. If you do the prime factorization of denominator, only the which prime number is required? Only the prime number, that is 2 and 5, or only 2 or only 5. Like for example 1 by 2, it is 0.5. So again if you see the denominator is only 2. 1 by 5, it is 0.2, or 1 by 10, 0.1. 1 by 10 means nothing but 2 and 5. So denominator should have only 2 as a prime number, or 5 as a prime number, or 2 and 5 as a prime number. No other prime factor is required. For example 1 by 15. 1 by 15, whether it will be a terminating or non-terminating decimal expansion. So do the prime factorization first of all. Check any other common factor is there between numerator and denominator. No, there is no any other common factor. So after looking at that, now do the prime factorization of 15. So 1 upon 3 into 5, that is the prime factorization of 15. So 5 is there, but apart from 5, one other prime number is there, that is 3, which is not required in order to call this expansion as a terminating decimal expansion, because here 3, it is not only 2, it is not only 5, it is not 2 and 5. Apart from 2 and 5, there is other prime number is there, and hence this 1 by 15 will be called as a non-terminating decimal expansion, right? So the power of the denominator, the power of denominator should be 2 to the power of anything and 5 to the power of anything. 2 to the power of m is any number, and 5 to the power of n. No other, I am telling you, no other prime factor is required. If any prime factor is there in denominator apart from these two, that number will always going to be a non-terminating decimal expansion, right? So if you can convert your denominator as a power of 2 and 5, then it is a terminating decimal expansion. If you cannot convert as the denominator as a power of 2 and 5, then it will be a non-terminating decimal expansion. Is it clear? Now it will make sense. I'll explain in your exercise. So now let us move towards your exercise number 1.4. Okay students, so first question is of your exercise number 1.4 is, without using long division, without doing the long division, state whether the given rational number will terminate or it will not terminate. So you have provided by all the rational number, there are total 10. I selected 6 of them, right? So 6, I took 6, there are 10 in your textbook, you can solve the remaining 4th one. So there are 6 rational number are given, and you have to state whether the given rational number will terminate or not terminate, right? And second question will also go hand in hand. What is telling you? Find the answer of question number 1. Find the answer means if it is a terminating If it is a terminating, you are getting a terminating decimal expansion. Suppose this number is you are getting as a terminating answer. So you have to answer it. What is the answer of that terminate? What is the answer of that termination? Like 1 by 2 is the rational number. Then you answered it that it is a terminating. Then what is the answer of 1 by 2? So you will say 0.5. So again, that also you have to do it without doing the long division method. So without doing the long division method, whatever question which is terminating in the question number 1, you have to find out its answer. If it is non-terminating, then you don't have to touch it. Only you have to find out the answer if it is a terminating decimal expansion. All these six questions. So that's question number 2. I will solve it with question number 1. And question number 3, I will come later on. So first thing, let me take first example. That is 13 upon 3125. You have to answer it whether this number will terminate or non-terminate, but you don't have to do the long division. Means you cannot apply that division methodology. So for that, let us do the prime factor. Before doing the prime factor, just let's check if both are having any common factor. I don't think so. 13 is a prime number and 3125 is not coming in the table of 13. So both are not having any common number, which means they are co-prime number. Now do the prime factorization. Prime factorization of 3125. So how you have to do? You're doing the lower standard 3125. So 3125. So I think it is coming in the table of 5 prime number. So 5 6 are 30, 5 2s are 10, 5 5s are 25. Again this coming in the table of 5. So 5 1s are 5 2s are 5 5s are. Again 5 2s are 10, 5 5s are 25. Right? Again 5 5s are 25. Again 5 1s are. You should get 1 here. So here 3125 is nothing but 5 into 5 into 5 into 5 into 5 times. That is equal to 5 to the power of 5. Are you getting any other prime number other than 5 or 2 or anything? Like 5 is, I can accept 5. 2 also I can accept. Is there any other prime number you are getting in the prime factorization of 3125? No. You are getting the power of 5, which allows you to call it as a terminating decimal expansion. So here the denominator, the deep denominator part is in the power of 5, in the power of 5. Therefore 13 upon 3125 will have a terminating decimal expansion. Terminating decimal expansion. Right? Now you got to know that terminating decimal expansion. Now what is the answer of it? Because I have to solve the question number 2 also. So if it is a terminating, you have to find out the answer again without doing the actual division. So the process is quite simple. Now if I convert here, so it is 13 upon 3125 is nothing but 5 to the power of 5. 13 upon 5 to the power of 5. Right? 3125 is nothing but it is 5 to the power of 5. Now to get the answer, like you know that if 1 upon 10 is there, I can easily call it as 0.1, right? Without doing any division. If 1 upon 1000 is there, again you can tell it at 0.001. 1 upon 100 is there, you can say it 0.01. 13 by 100 is there, then also you can say that 0.13. So if your denominator is converted in the form of 10, 100, 1000, lakhs, then you can find the answer without doing the division. That is the only logic. If you're having 5, what you multiply in the 5 to make it as a 10, so you will multiply 2. If 25 is there, what you will multiply to make it as a power of 10? So 4 is nothing but 2 square, 25 is 5 square, and 4 is 2 square. Only logic I want to tell you that in order to find the answer of the terminating decimal expansion, in order to find out the terminating decimal expansion, in the denominator, power of 5 and power of 2 should be equal. Power of 5 and power of 2 should be equal. If it is not equal, then you have to purposefully make it equal. Meaning to say that here power of 5 is 5. So can I say that here power of 2 is not there? 2 raised to 0 is there? 2 raised to 0 is 1. So power of 5 is 5 and power of 2 is 0. So in order to get 10, 100, 1000 lakhs, the power of 2 is also should be 5. So you have to do multiply, you have to divide by 2 raised to 5, but you cannot do only division. In order to cancel it, in order to make it balance, you have to multiply by 2 raised to 5 as well. So ultimately, to balance the power of 5, you have multiplied 2 to the power of 5 in the denominator. Same thing you have to do in the numerator as well. So by doing this thing, what will happen? 13 into 2 to the power of is nothing but 32, and this will come 5 2s are 10, 10 to the power of 5. Bases are powers are same, so we can multiply the base. So 5 2s are 10, 10 to the power of 5. Now 32 into 13, 32 into 13 is what? 3 to 6 is 9, 2 1s are 2, and 3 1s are 3. So 6, 11, 4. Right? Yeah, 416. So you are getting 416, and 10 to the power of 5 is nothing but 10 lakh. Sorry, 1 lakh. 1 lakh, right? So if 100 is there, so you are putting decimal after 2 digit. If 1000 is there, you have to, 1000 is containing 30. So you are putting the decimal after 3 digit. So lakh is containing 5 zeros. So your decimal should come after 5 digit. So 6 is there, 1 is there, 4 is there, 1 more 0, and 0. So after 5 digit, you are getting the 0. So 0.00416 is your answer of this 13/3125. So we got it as a terminating. How? Without doing the long division, the power of the prime factorization of 3125 is containing the power of only 5. So it will have a terminating decimal expansion. Now, if it is a terminating decimal expansion, in question number 2, you have to find out the answer. To get the answer, the power of 5 and power of 2 in the denominator both should be equal. So whichever is higher, by multiplying it, you have to make it balance, right? And why we are making the power balance of 5 and 2? Because it will convert it as a 100, 1000 and lakhs and whatever, which will make your division very, very simpler. I hope you have understood. Let us take the second example. Now if you look at question number 2, 17 by 8. So first question you have to ask yourself, is there any other common factor? No, they cannot be cancelled further. So 17 by 8 is a proper rational number. Now if it is a proper rational number, do the prime factorization of the denominator. So 8 will have a prime factor as 2, 4s are, 2, 2s are, 2 1s are. So 8, it can be written as 2 into 2 into 2, that is 2 cube. So 17 upon 2 cube. Okay. Are you getting any other common factor, any other prime number other than 2 and 5? No, you are not getting any other prime number which are, what is the only prime number which is required in the denominator? Only 2 and 5. So only 2 is there, only 5 is also allowed, and 2 and 5 both are also allowed. So we are not getting any other prime number apart from 2 and 5. So it will have a, simply you write down, it will have a terminating decimal expansion. Terminating decimal expansion. Now if you got the terminating decimal expansion, what is the next job? You have to solve the question number 2 also. You have to get the answer without doing the long division. So here 17 upon 2 to the power of 3 is there. So I told you the power of 2 and 5 should be balanced. If 5 is not there, means its power is going to be 0. So what you have to do? You have to make it 3, because 2 to the power of 3 is there. So 5 should also be having power 3. So by yourself, 5 to the power of 3 multiply and 5 to the power of 3 divide. So it will become 17 into 125, 5 cube is 125, and that will become 5 2s are 10, 10 cube. So find the answer of 125 and 17. So 5, 12, 11, 2. 2125. 2125 by 1000. So your answer is 2.125. 2.125. Let us check the division once more. 7 5 is 35, 7 to 14 plus 3 17, 7 7 to 8, 5 1s are 5, 2 1s are 2, 1 1s are 5, 12, 11, 2. Okay, 2125 by 1000. So 2.125, that is your final terminating answer. Power of 2, only 2. Okay, no problem. Terminating decimal expansion to get the answer. Power of 2 and 5 is balanced. So which is required thing? 5 is required thing. What is the power? What is the power of 5 should be? 3, because 2 is also 3 here. So 5 cube and 5 cube. Multiply it, convert it as a 10,000 or lakhs, whatever, and you get the answer. Now the third question is 64 upon 455. First of all, no other common factor is there. No other common factor is there. So directly do the prime factorization of 455. 455, I think 5 will be there. 5 9s are 5 1s are, 7 13s are, and 13 1s are. So 455 is equal to 5 into 7 into 13. So here if you see, you are getting other prime number apart from 5 and 2, you are getting one more prime factor, 2 more prime factor, 7 and 13. That is not allowed. No other prime factor is required other than 2 and 5 or 2 or 5. So here you are getting prime number 7, prime number 13. So here you will write that 455 prime factorization of 455 is cannot be converted as a power of 2 or 5. Therefore it will have a non-terminating decimal expansion. It will have non-terminating decimal expansion. I hope it is clear, right? Because here you are getting 7 also, not allowed. Any other prime number apart from 2 and 5 is not allowed. If it is there, the number will be a non-terminating decimal expansion. It is a rational number, but it is non-terminating and recurring. If you divide it, you will get a recurring answer, but you don't have to solve. So if it is a non-terminating, you don't have to solve the question number 2. You have to solve only question number 2 only and only when a decimal expansion is a terminating one. So it is a non-terminating one, so you don't have to move forward. Okay. So I hope you will be able to solve the 15 upon 1600. Let us take the fourth question also. Okay students, so 15 upon 1600. Now they will have a common factor because 5 is there, 0 is there, so it can be cancelled with 5. So 5 3s are 15, 5 3s are 15, 5 2s are 10. 3 upon 320. 3 upon 320. That is your proper rational number. See, so the first job you have to check whether they are having a common factor or not. If common factor is there, you have to cancel it out and you have to convert as a co-prime numbers. Now 320 is there. So write on 320, find the prime factor. 2 1s are, 2 6s are, 2 0s are, right? 2 8s are, 0s are, 2 40s are, 2 20s are, 2 10s are, 2 5s are, 5 1s are, right? So 2 16s are, 2 8s are, 2 4s are, 2 20s are, 2 10s are, 2 5s are, and 5 1s are, correct. So here 320, it can be written as 2 into 2 into 2 into 2 into 2 into 2, I think 6 times, right? 2 4 6 into 5 into 5. So it is 2 to the power of 6 into 5 to the power of 1, 5 to the power of 1, right? So yes, are you getting any other common prime factor other than 2 and 5? No, they are 2 and 5 only. So it is required. No other prime number should be there. So yes, it is a terminating decimal expansion. If it is a terminating decimal expansion, you have to find out the answer as per the question number 2. So 3 upon 320 is equal to 3 upon 2 to the power of 6 into 5 to the power of 1. So here 2 is having power 6 and 5 is having power 1. So you have to convert your 5 as a power of 6. So here you have to multiply 5 to the power of 5 and here also 5 to the power of 5. Right? So this will become 3 into 5 to the power of 5. Right? And this will become 2 to the power of 6 into 5 to the power of 6. Right? So 5 to the power of 5 is nothing but 125 into 25. Right? 125 into 25. So 3 into 125 into 25 upon 10 to the power of 6. So it is nothing but 10 lakh. So 10 lakh will have 6 0. Multiply this entire thing and put decimal before 6 digit. Right? I hope you will be able to solve it. So here we have finished question number 1 and 2. Rest all the question you have to follow the similar manner. Suppose the power is already 13 upon 2 raised to 5 and 5 raised to 3. So directly you don't have to go for the prime factorization because it is already converted as a prime factorization. If any other prime number is there, you simply have to write no, it is not a terminating decimal expansion. It will be a non-terminating decimal expansion. I hope it is clear, right? Let us move towards the last question of this chapter, question number 3. Okay students, so question number 3, what it tells you, state whether the given decimal expansion are rational or not. If it is the rational, convert in the form of P by Q. So you are provided by 3 questions and you have to first of all decide whether it is a rational or it is irrational. If it is a rational, then it is in the decimal form, you have to convert it into the format of P by Q. So if you look at the first question, what is the first question? 43.12345678 So it is quite simple, you have already done that. For example, suppose 1.23 is there, so you are writing it as 123 by 100, isn't it? If 0.1 is there, you are writing 1 by 10. So whatever digit is there after decimal, that much 0 should be there in the denominator. So if you look at here, 33639 is there. So that number, if I take it as x, so that number will be 43, 1, 2, 3, 4, 5, 6, 7, 8, 9 upon 1. And how many 0? Whatever digit is there. 3, 6, 9. So 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 9. That is a P by Q format. So first of all, it is a rational number. Yes, it is a rational number. Why? Because it is having a terminating decimal expansion. And if it is terminating, then convert it. So it is quite simple. So just remove the decimal, and whatever digit is there after decimal, that much 0 should be there, accompanied with 1 as a format of P by Q. That is quite simple. First one is done. Again, I think this all question you have done in the 9th standard. The similar process is there. Now in the question number 2, 0.12012001200 again I have explained this thing. This is a non-terminating, non-recurring. 120 1200 so dot is there, means it is a non-terminating, and no specific number. See 120, so 120 should repeat, but it is becoming 1200. So 1200 should repeat, but it is becoming 12,000. So no specific number is repeating again. So it is a non-terminating, non-recurring, recurring. So what is that? This is an irrational number. Irrational number. Right? I hope it is clear. This one is a rational because it is a terminating. This one is a it is a irrational because it is a non-terminating and non-recurring. So let us move toward the last question of this chapter. Okay students, so last question is 43.12345678 in bar. The bar itself suggests to you that number is a non-terminating but recurring. Recurring means what? This all number is repeating again. This all number is repeating again. So it is a non-terminating and recurring decimal expansion. So it is a rational number. It is a rational number. Now if it is a rational number, you have to convert it in the format of P by Q. So for that, what you have to take, this is the specific method you might have learned in the 9th standard. If a non-terminating recurring number is there, you have to take that value as x. So x is equal to 43.12345678 and on whichever number the bar is there, that number is repeating itself again. So bar is there on entire number. So meaning to say that after this 9 digit again 1 2 3 4 5 6 7 8 9 and again 1 2 3 4 5 6 7 8 9 is there. It is going on and on. So a particular specific number is repeating after 9 digits. So it is a non-terminating but recurring. So I have to take it as x and I have to give it as equation number 1. What I am doing? I am converting in the format of P by Q. So this is the procedure for every non-terminating and recurring number. So I have converted into the x. Now decide after which digit your number is repeating. So 3, 36, 39. After every 9 digit your decimal is repeating. So what you have to do? You have to multiply this x with 10 to the power of 9. 10 to the power of 9, why? Because after 9 digit your decimal is repeating. If you suppose after 2 digit your decimal would have been repeating, so I would have done what? 10 to the power of 2, because after 2 digits your decimal is repeating. If 3, after every 3 digit if decimal is repeating, so I would have multiplied here 10 to the power of 3 into x. So here, because your digits are repeating after every 9 digits, so I will multiply 10 to the power of 9 on both the side. So multiply 10 to the power of 9 on both the side. So this will come 10 to the power of 9x, and you know that if 0.23 is there, 231 is there, if you multiply by 100, so this decimal will shift after two digit. So if you multiply by 100, so it will give you 23.1, right? If you multiply by 1000, so this will become 231. Decimal will shift after 3 digits. So if you multiply 10 to the power of 9, this decimal will shift after 9 digit. It will come after 9 digit. So if you multiply this has become 10 to the power of 9x. And because you have multiplied 10 to the power of 9, this decimal will come here after 9 digit. 3, 6 and 9. So this will become 43, 1, 2, 3, 4, 5, 6, 7, 8, 9. Point 1, 2, 3, 4, 5, 6, 7, 8, 9. And so on and on. That you have to give it as equation number 2. Okay. Now the next part, you have to subtract the bigger equation minus the smaller equation. That is the process, right? So subtract equation number 1 from equation number 2. So if 100 is there, if you subtract 1, you will get 99. If 1000 is there, if you subtract 1, you will get 999. So from any 100, 1000 and lakhs, if you remove 1, whatever amount of 0 is there, that much amount of 9 will come. Meaning to say that 10 to the power of 9x is there. So how many zeros are there? 9 zeros are there. And if you subtract this from 1, that is 1x only, no? 1x. So if you subtract 10 to the power of 9x minus 1x, you'll get 9 times 9. Like see here, 10 to the power of 9x is 3, 6, 9x, right? 3 plus 3 plus 3, 6, 9, 9x. Okay, it is nothing but 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Point 1, 2, 3, 4, 5, 6, 7, 8, 9. And here second equation is x. It is what? Decimal. You should have decimal below decimal. So it is 43 points. So 43.1, 2, 3, 4, 5, 6, 7, 8, 9. And so on. So if you subtract, see this 9 minus 9, 0, 8 minus 8, 0, 7 minus 7, 0, 6, 6, 0, 5, 5, 0, 4, 4, 0, 3, 3, 0, 2, 2, 0 and 1, 1, 0. So that is 0.0. That is the logic why you have multiplied 10 to the power of 9. Because it will make the digits similar. So it cancel. 9 minus 3 will give you 6. 8 minus 4 will give you 4. And rest every digit will remain as it is. 7, 6, 5, 4, 3, 2, 1, 3, 4. Right? And here, because this is something 100 crores. 100 crores. So if you 100 crores, if you subtract 1, you will get whatever amount of 0 is there, that much amount of 9 you will get. So 3, 3, 6, 3, 9. So 3, 6, 9x. That's it. Now you have to find out x. You have to convert this. You have to suppose this as x. So x is equal to 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6. 0.0 you don't have to write. Upon 999, 999, 999. And that is your P by Q format. That is your P by Q format. Right? So this is how a number can be converted, can be said as a rational or irrational by converting it as a prime factor of 2 and 5. If it is prime factor of 2 or 5 or both, then and only then it will be a terminating decimal expansion. And to get the answer, you have to make your denominator similar power of 2 and 5. You have to make the power of 2 and 5 as similar. Whatever is missing, that you have to multiply and divide it. So the denominator will be converted in the format of 10,000 lakhs. So you can easily divide it without using a long division. And if your number is terminating, it is a rational. If it is a non-terminating but recurring, then it is a rational. If it is non-terminating, non-recurring, it is irrational. So here you can easily convert. And for such kind of thing, where non-terminating and recurring numbers are there, so you have to convert it as x, and after whichever value your number is repeating, that much times you have to multiply with 10, and you have to do the subtraction, right? So this is how we have finished the entire chapter of real number. I hope you have understood. Please note it down in your notebook. Whatever doubt is there, feel free to ask, and in the next video we will be solving the new chapter. Till then, bye bye and take care of yourself.